In lecture 8 we will discuss the Laplace transform property known as time scaling. Okay, and also we'll discuss some problems related to this time scaling property. First we can explain what do you mean by time scaling property. Okay, so this is the general equation for finding Laplace transform. X of s is equal to integral minus infinity to infinity x of t e raised to minus st dt, and assume that x of s is a Laplace transform of the signal x of t, and the ROC is represented by letter R. Now we can see that there is a signal which is a time scaled version of signal x of t, okay, and which is represented as x of a t, and this a can be positive or negative. So the Laplace transform of the signal we can directly write by using this formula. This is 1 by modulus of a x of s by a. Okay, there is one important point you need to remember. The amplitude is scaled by the factor 1 by modulus of a. Means if this a value is negative, for example it's minus 2, but when you multiply the amplitude part it's simply 1 by 2 because we are taking the modulus, but the s value is changing to s by minus 2. Okay, that's the difference. In one place we will use modulus, and inside this or s we will replace by s by a. So here we need to use the sign. Okay, and this is the ROC. ROC is simply multiplied by that a into R, but we need to take some care when you multiply this. We'll discuss that concept in when you do the problems. Okay, if it is negative we need to do some changes. Okay, that we will discuss in when you do the problem. First we will discuss a question. Find the Laplace transform and ROC for the signal x of 3t. Okay, where x of t is given by e raised to minus t into u of t. So first we need to find the Laplace transform of x of t, and then we need to apply the formula time scaling property to solve this particular problem. Okay, so first we can take the general formula. Okay, e raised to minus 18 into u of t is 1 by s plus a, and sigma greater than minus a, that's ROC. So based on that you can write this e raised to minus t. So e raised to minus t into u of t can be written as 1 by s plus 1 and sigma greater than minus 1. So this is about I can say that this is x of t, and the given quantity is x of s. It will be okay. Now we need to find out the Laplace transform of x of 3t. Okay, so x of 3t is means t we are changing to 3t. So the equation becomes e raised to minus 3t into u of 3t, so because we are changing t to 3t. But we can directly write the result by using this particular formula. First step, if it is a, you need to write 1 by modulus of a, so it becomes 1 by 3. So here a is positive. Then you need to write x of s by 3. So we can try how we can write like this. 1 by 3 into x of s is given is 1 by s plus 3. So we can write in place of s you need to write s by 3. So we will replace s with s by 3 plus 1. So if you modify this you will get 1 by 3, and there will be 3, and if you take the LCM denominator it becomes s plus 3. So here you can see that 3 cancels, and is simply s plus 3. And about the ROC, initially the ROC is sigma greater than minus 1. So now we can see that it's a into R, means we need to multiply by this constant a. In this case a is equal to 3. So you can write ROC is sigma greater than minus 1 is already there, minus 1 into 3. Okay, so sigma greater than minus 3. So we can plot the ROC like this. This is sigma axis and this is j omega axis, and this is a point -3, and ROC is sigma greater than -3. So in this plane, if sigma is greater than -3, the transform exists. Okay. So directly also we can try this particular problem, because we can verify this particular answer, because you already know this type of signal. Okay, e raised to -3t into u of 3t. So again there is a confusion. This is u of 3t. What do you mean by u of 3t? So I will just write what is u of 3t. U of 3t, if you write, is equal to 1 when 3t is greater than 0. When 3t is greater than 0 means, or you can write t greater than 0. And similarly, it's 0 when 3t is less than 0 or t less than 0, means there is no change in the signal, step signal, if you apply scaling property, because this is equivalent to simply u of t. Okay, u of t is equal to 1 for t greater than 0 and 0 for t less than 0. We will get the same answer. So u of 3t and u of t are same. So the equation becomes e raised to -3t into u of t. So based on the standard result, you can write simply 1 by s plus 3 and sigma greater than -3. So in this problem, first we applied the time scaling property to solve x of 3t, and second we just verified that answer, whether the answer 1 by s plus 3 is correct or okay. Now we need to do another problem. It's again an interesting question. X of t is equal to del of a t plus b, where a and b are real constants. So we need to find the Laplace transform of this signal. Okay, most of the time we will directly apply the time scaling property here. So first we can try what is the Laplace transform of del of t. Okay, del of t is equal to 1, or Laplace transform of del of t is equal to 1, and ROC is all s. Okay, now we need to find out the signal, Laplace transform of the signal del of at plus b. But in order to apply the property, first we need to rewrite this equation. This is, if you take a common, then you can write t b by e. Okay, so now it's a scaled version. Okay, just like in a del of at form. But if you directly apply the scaling property, there is also shifting also. So here you can see that there is a shift. But when you do this problem, you always remember this is an impulse signal. When it is del of at, so I will just go to an important property of impulse. Del of at is equal to 1 by modulus of a into del of t. So this is the scaling property of an impulse signal. Okay, it's not the scaling property of Laplace transform, as a scaling property of impulse signal. So here we are discussing the scaling property of Laplace transform. So based on the scaling property of impulse signal, del of a into t plus b by a can be written as 1 by modulus of a del of t plus b by a. Okay, now if you look at this signal, the signal is del of t plus b by a, means there is a time shifting property we need to apply, not time scaling property. Most of some students make mistake, they will directly apply this time scaling property by seeing this del of a into t. But for the impulse signal, it's very important. For the impulse signal, there is a scaling property. First we need to apply the scaling property. So you will get a new signal which is del of t plus b by a. Now this is the time shifted version of an impulse signal. Now we need to find the Laplace transform of this particular signal by applying time shifting property. So time shifting property, we already discussed time shifting property. So this is the time shifting property. If there is a signal and the time shifted version is available, you need to multiply that exponential term e raised to minus s into t0 if it is t0. So now in place of this t0, it's plus b by a. So I can write like this: e raised to s into b by a, okay, into the Laplace transform. So Laplace transform of del of t is 1, so we can write 1. Okay, for when you apply the time shift property, there is no change in ROC, so ROC all s. Okay. Now in this question there is a constant also, so we need to multiply by this constant. So the final answer, so if you multiply by that constant, it's 1 by modulus of a. So here also we need to multiply by that constant. So this is the Laplace transform of the signal del of at plus, so del of at plus b. The Laplace transform can be written as 1 by modulus of a into e raised to s b by a, okay, and ROC is all s. Okay. Next we will discuss another question. Find the Laplace transform and ROC for the following signal x of 2t and x of minus 2t. Using the time scaling property, also verify the answer. If x of t is given, e raised to minus t into u of t minus e raised to 2t into u of minus t, and x of s is equal to, so the Laplace transform of this particular signal is already given. X of s is equal to a numerator 2s minus 1 and denominator s plus 1 into s minus 2. Okay, ROC is between minus 1 and 2. Okay, the Laplace transform is already given. We need to find out x of 2t and x of minus 2t. So by applying the time scaling property, we can find out x of 2t. Okay, x of 2t, the Laplace transform we can find out by applying the property. It's 1 by modulus of 2 x of s by 2. So if you apply this 1 by 2, we need to replace s by 2. Okay, here we need to write s by 2 minus 1, so that is a numerator, and now we need to write a denominator s by 2 plus 1 into s by 2 minus 2. Okay, if you simplify this, these two cancel. Okay, so simply it's s minus 1, and if you take the LCM here, 1 by 2, and here it becomes s plus 2, and the denominator 2 becomes 2 here. Then second term, it's s minus 4, and the denominator 2 becomes numerator. So finally you will get 2 by s plus 2 into s minus 4. Okay, this is about x of 2s, sorry, x of 2t. Sorry, one more term, there is s minus 1. Here it is s minus 1. So you are getting 2 into s minus 1 by s plus 2 into s minus 4. Now about the ROC. So ROC, already it is given minus 1 to 2. Now we need to multiply by this constant a. So here that constant is 2. So we need to multiply 2 here. So minus 1 into 2. Here also 2 into 2. So it becomes minus 2 less than sigma less than 4. So your new ROC sigma, this is the j omega axis. Here it is minus 2, here it is 4. So it's from minus 2 to 4. Okay, initially it's from minus 1 to 2 for this particular signal. Now it is expanded. okay, by this value 2. Now we need to verify whether you will get this particular answer. Okay, here we are getting 2 into s minus 1, s plus 2 into s minus 4. We can directly approach this particular problem. So we need to find out x of 2t. X of 2t can be written as, here x of t is given, we can replace t with 2t. So it's e raised to minus 2t, u of 2t minus e raised to, if t is replaced with 2t, it becomes 4t into u of minus 2t. Okay, so here you can see two terms, u of 2t, u of 2t is equal to 1 for 2t greater than 0, or you can write t greater than 0, and 0 for 2t less than 0 or t less than 0, means there is no effect if you scale a step signal. So u of t, which is equal to u of t. So we can replace this with u of t. Here it is u of t. Here we can replace with it's minus 2t, so we can write u of minus t. Now we can write the Laplace transform directly. So this quantity is we can write 1 by, it's a causal signal, so 1 by s plus 2, and ROC is sigma greater than minus 2. And here it is an anti-causal signal, so anti-causal signal you can write 1 by s minus 4, okay, in sigma less than 4. So you got two quantity. So ROC you need to verify in order to apply the linearity property. Now two signals, so we need to apply the linearity property here. If you apply the linearity property, you can check one signal exists if sigma greater than minus 2, and another signal exists when sigma less than 4. So there is a common area between minus 2 and 4, so we can combine the result. So x of s can be written as 1 by s plus 2 plus 1 by s minus 4. So after simplification, s minus 4 plus s plus 2 divided by s plus 2 into s minus 4. So we will get 2 s minus 1 divided by s plus 1, sorry, s plus 2 into s minus 4, and ROC is from minus 2 to 4. So if you check the previous case by using time scaling property, already we got the result, okay, and now without using the property of time scaling property, we tried this particular problem, so we got the same answer. So we verified the first case. Now we are moving to the second case, x of minus 2t. You need to take some care when you do the negative scaling, okay, and by applying the property you can say that it's 1 by modulus of 2 x of is very important, you need to write the minus 2 here, okay. So minus 2, you need to write minus 2. So by applying that, it becomes 1 by 2, and you need to apply 2s by minus 2 minus 1. In place of s, you need to write s by minus 2, and the denominator becomes s by minus 2 plus 1 into s by minus 2 minus 2, okay. So after simplification, it becomes 1 by 2, numerator it becomes if you take minus 1 common, it becomes s plus 1, okay, and denominator it's s minus 2 and s plus 4, and the numerator there will be minus 2 into minus 2. So finally you will get 2 get cancelled, so there is a minus after simplification, this minus 1, minus 2 and minus 1. Okay, after cancelling this minus 1 minus 2, it becomes minus 1. So we got minus 2 into s plus 1. And about the ROC, initially it is given minus 1 sigma and 2. Now you need to multiply by a, so here a is equal to minus 2. So here we need to take some care. So minus 1 into minus 2, and here it is 2 into minus 2, means we are multiplying by a negative quantity, so definitely we need to change this sign. So initially it's less than, now we need to change it to greater than. Why? Because minus 2 is greater than minus 3. If you multiply with minus, it becomes 2 and 3, so you need to change the sign. So based on that, in your ROC now, you can write minus 4 less than sigma less than 2. So your ROC is changed in the reverse direction. So this is j omega axis, here it is minus 4, here it is 2, and greater than minus 4 and less than 2. Okay, so this is the answer and this is the ROC. Now we can verify this particular by using direct method. So we need to write x of minus 2t. So I can write e raised to minus 2t. If you replace t with minus 2t, it becomes a raised to 2t, and u of minus 2t minus e raised to minus 4t into u of plus 2t. So I can rewrite like this: e raised to 2t, e raised to u of minus 2t can be written as u of minus t minus e raised to minus 4t into u of t. Now we can write the Laplace transform directly here. This is an anti-causal signal, so anti-causal signal, but there is no negative, so in the result there will be negative 1 by s minus 2, and sigma is less than 2, and here it is 1 by s plus 4 and sigma greater than minus 4. So you got two terms, and we can verify whether is ROC, common ROC. So this is sigma, and this is minus 4, and this is 2, and greater than minus 4 and less than 2, so there is a common area. So we can write x of s, or the new signal x of s like this: minus 1 by s minus 2 minus 1 by s plus 4. So after simplification, we'll get minus s minus 4 minus s plus 2, and the denominator it becomes s minus 2 into s plus 4, and the ROC is minus 4 less than sigma less than 2, and if you simplify this numerator, it becomes minus 2 s plus 1. Okay, and denominator is s minus 2 into s plus 4. So we got the answer which is similar to the previous one. Okay, both answers are same, so we verified this time scaling property. Okay, thank you.